All right. As always, we get started. You know anybody out there, they can catch the previous episodes we done. We appreciate if y'all tell people about it, have them come over and subscribe. Uh, you know, it's amazing me because I look on there and I see how many views are on there. We don't have that many subscriptions compared to how many views. Uh,
Yeah.
I think just the last month we had, uh, I think we're up like 2,800 views or something. And these are all different ones. So,
Right.
at least subscribe. We're getting it to you for free. I mean,
So
even if you don't
hit
ever come
that
back and look at it, it's just a subscription that just shows we have people watching.
hit that thumbs up and hit that subscribe.
Yeah, we appreciate that. All right. This week, what we're getting into is finishing up. We went through all the box fill last week, and this was the homework portion here. And we're going to be looking at the round optical boxes, and we'll get into the device boxes and square boxes, and then other boxes. And then we'll start calculating for the rest of the wiring methods. And we'll and when we come back next week, we'll go through that. Then we're going to start doing calculating conductor ampacities. And we're really going to start getting into the meat of where most people have the problem with calculations. But don't worry, by the time we go through, you're going to be like, this is not hard once you understand what you're looking for or where to go. It's just like these box fill calculations. Last week we went through the start of it, talking about the method of that you will do in order to count the conductors. And that's what we're going to reemphasize here this week. So if I look at this, you'll notice in the illustration we have a canopy. Now, if I have 4 or less wires and are 14 or less in size, then I don't have to count those conductors. So you're going to see here we got number 18 wires for our fixture wires. So we're not going to count that, okay? Because we
Right.
do have the canopy. And that's over in 314.16B1 exception where you're going to pick that up. But now
Right.
I've got two number 12s coming in, two number 12 ground and neutral conductors. I have 2 equipment grounds, so I don't have more than 4, so I got to count at least one. I have a fixture stud and hickey. I got to count one for each one of those. So if I look over an exercise problem, you would be looking, we went over this last week, you'd be looking over at 314.16 B1 through B5. If I have 2 number hots, that's 2 conductors. 2 number 12 neutrals, 2 conductors. 2 number 12 equipment grounds didn't exceed 4, but I got to count at least 1, so that's 1 conductor. Then 1 conductor for the fixture stud and hickey, 1. And then, of course, I have a canopy, so I don't have to count any of the fixture wires. Add that up, that gives you 7. Then I go over, look at table 314.6a, pick up the number 12s on the top right-hand side, come down the next value above those 7 conductors. You come across, look to the left, and it's going to tell you for a round or optical box, you need a 4-inch by 2 1/8 inch box. Pretty
Nice.
simple. And and that's what makes this great is you can see by following along, once you understand the counting of the conductors and you know where the tables are, where you pick the sections up, right here, it doesn't get any easier than this. All you have to do is remember, if I'm doing any type of box fill calculations here, or I'm doing any type of pulls, I'm going to be dealing with any type of conduit bodies. All that stuff's going to be in Article 314. The sections you always want to concern yourself with are these: 314.16 B1 through B5, Table 314.16A, Table 314.16B, and 314.28A1 and A2. As long as you've
Right.
got all of those, you should be able to follow along with this very simply. Now,
Right.
the second part is different size conductors. Now, we got one number 12 hot. This is actually a simple one. We got a number 12 ground and neutral conductor. We have a number 12 equipment ground, and we have 2 number 16 fixture wires and 1 number 16. Now, you'll notice in this, and there's no canopy. Okay?
Right.
So if I look at the different size conductors in step 1, where we always start is 314.16 B1 through B5. for the method of counting our conductors. And now, since they're different size within the same box, I need to look at table 314.16b. That's where I'm going to get my cubic inch rating for each one of those conductors. And for number 12, it's 2.25. Okay? So
Right.
you got one number 12 uh, ungrounded phase conductor, one number 12 grounded neutral conductor, and one number 12 equipment grounded conductor. 2.5, 2.25, 2.25, and 2.25, A, B, and C. Now you're going to look
Right.
at your fixture line. You go over, look at table 314.16b, it's going to tell you it's good for 1.75. You take, multiply that by 2 because you got 2, that's going to give you 3.5. I've already counted for one of my equipment grounding conductors. You only got 2 in the box, you didn't do 4, so you'll get a 0. Add all that up together, you get 10.25 amps. Come down, look in the third column that's there, that's where your cubic inch rating is. Come down, look at the value that exceeds 10.25. Come across, it's going to tell you the box size needs to be a 4 inch by 1 1/4 inch round box.
So on just a quick question. So that box size should be in a table that's in 314, right? So
It'll
you
be in
should
table.
be
It'll be in table 314.16a.
nice. So you should be able to just go right over there, look at the table, and then find it. The other thing that I would add to this is, man, if my apprentice made up a light like that, I'd be like, "You're gonna leave it like that?"
Oh,
I don't know, man.
we just put it like that because we're trying to show there's no canopy. It,
All right,
it's
that's funny.
more, it's not a full installation. All we're trying to do there is get the conductors out so you could see the conductors and how to do the conductor
True.
fill. It,
No, it's a good illustration. I was just joking.
it sometimes it's hard when you're doing these illustrations because you got to have enough room up there to show exactly what it is you're trying to calculate. And
Right.
if you do it as a full installation, well, then you can't see what wires are there. And
Yeah.
when we're looking at this, we're mainly thinking to ourselves, we want them to be able to see what's here, and that's why we spend a lot of time putting these together like that.
I'm
Okay,
actually surprised the box screws are still in there. Usually they fall out.
yeah.
So.
Okay, now look at this. Here's a device box. The same thing. I got two number 12 hots, two number 12 neutrals, two equipment grounds. Now remember, we have a receptacle. If there's any device there, we have to count two conductors for each device. And then if you have a
Right.
bonding jumper, it's in there, we don't count the bonding jumper. Okay?
Right.
So if I look at my same size conductors in step one, you got your two number 12s, ungrounded phase conductors, two number 12 ground and neutral conductors, two. You got two number 12 equipment grounds, one. You got one receptacle, count two conductors. Bonding jumper, count as none. Add that up, that gives you seven conductors. Go over to the top right hand side of table 314.16a. Pick up number 12, come down the next size above seven, and look over to the left for device boxes. And it's going to tell you need a 3 inch by 2 inch by 3.5 inch device box. Okay. Now, the interesting thing I like to say about this, if you notice, I have not changed the calculations at all. I'm still in the same sections. I'm doing everything the same. The only thing I'm doing is when I get over to the left hand side of table 314.16a, I'm either looking at round or optical boxes, I'm looking at device boxes or square boxes. Okay. Now, the next one is different size conductors, the same calculation. You'll see we got one number 14 ungrounded phase conductor. I got one number 14 grounded neutral conductor. Now, this is the one you need to look at here because if you look at the illustration, we're showing you the number 14s are passing through and the number 12s are connecting to the device. So that's going to tell me right there when I take the two conductors for that device, that's what's connecting to it. So I'm going to base it off of that cubic inch that's connected to it. So we'd base it on the number 12s, not the number 14s. Okay. So when I go down, I've got one number 12 ungrounded phase conductor, one number 12 grounded neutral conductor. I have two number 12 equipment grounding conductors, one receptacle, and a number 12 bonding jumper. So I'm going to come over and decide what I need here. Now, if I look at table 314.16b for a number 14, that's going to give you 2 cubic inches. So 2 and 2 for the hot and neutral. Then I've got the hot and neutral is a number 12 that's connected to the device, and table 314.16b says the cubic inch is 2.25. So I'm going to add that all the way down, and I got to count 1 for my equipment ground, which is 2.25. Then you take the receptacle, the number 12 is connected to it. So I'll take the 2.25 times 2, and that's going to give me 4.5. I get a 0 for the bonding jumper. Add all that together, gives you 15.25 cubic inches. I'll go over, look at table 314.16a, come down the third column in the cubic inch, find the cubic inch that's above the 15.25, and that's going to tell you for the device box, you need a 3-inch by 2-inch by 3.5 inch. Okay?
Nice. So you actually count those ones passing through as one each, right?
Yeah, just one each. And then where it's connected to the device will be based on the conductor that's connected to it.
Gotcha.
Okay.
Okay.
Now, I will point something out, since we did this earlier, that pigtail that's going over that you're using as equipment bonding jumper, that will not be a number 14. That'll be a number 12.
Gotcha.
Okay? Because that's what's connecting to it. All right?
Right.
Now,
gotcha.
This is where you get into a square box. Now, what I like to point out, now we got cable clamps here, and looking at 314.16b3, we did this the other day, and you're going to need 1 count for the cable clamps that are there. Okay, they're internal cable clamps. Now, as I look at this, you'll notice we have 4 equipment grounds. I'm only have to count 1, but if I had 5, 6, 7 in there, then I'd have to take and put a quarter on that. So I'd have to multiply the additional by 0.25 like we did last week. Now, I've got 4 number 12 ungrounded phase conductors. I got 4 number 12 grounded neutral conductors, and I have 4 number 12 equipment grounds, and I have 2 cable clamps. Now, there is something I want to point out here. This will be a trick on the test. Anybody watching this needs to pay attention to what I'm saying right now, because when you get over there, you're going to start to see that when you get into sizing, there will be different size boxes you can get in there. And you may look at one that'll fit, but remember, they're going to take what is the minimum one there. Okay. So in this case, if I look at this, instead of it being a 2-inch by 1.25 inches, let's say, instead, it ended up being a 4/11/16 by 1.25 inches. That's going to be the smaller box that could be put in there. Okay.
Right.
And you have to go and look at that, because that's going to be over there. And it's funny because I caught this, God, I guess it's about 25 years ago. And I was going through the calculations and everything. And I went in and asked Dad, and I said, if I'm looking at it, he goes, you know what? He said, we got a mistake there. He said, but I want to leave it the same. He goes, that's a good teaching point, because on the test, if they put the minimum size box, that's what you're going to go with. He goes, that would actually be the correct answer. Okay. So I just wanted to point something like that out, because more than likely somebody probably put a different box size here, but actually this was the minimum size.
Well, and that's a good point too, James. That's a trap that a lot of these apprentices have to watch out for. That they're not just going with a little bit larger just in case. Because I was kind of doing that. I remember that when I was taking my test, I was like, oh, I should be covered if I go with 2 sizes up, But they put the 2 size up one on there as one of the answers. And you think, oh, cool, I got the right answer, but they want to know what the minimum size is.
That's right.
So,
and that's why we have certain calculations in here that way. So you go in and you see why we did what we did. Because, the main thing, we want people to pass, but you need to know all the tricks that are there. Yeah. And that's why we have it in here like this. But anyway, So I had four ungrounded phase conductors, four conductors, the neutrals four. I had four equipment grounds. I don't have more than four, so I got to count one. I had two cable clamps. I had to count one. That gives me 10 conductors. Pick up your number 12, come down the next size above that, look across, and it's going to tell you the minimum size there is a 411/16 by inch and a quarter square box. Okay?
Right.
Now, anybody that's watching this, you'll notice, have I changed my calculations any? No, it's just based on the total count and whether it's same size or different size conductors. I'm still following the same format I started with. So
Right.
if I look here, the same thing happens. I've got uh, different size conductors here. I've got number 12s and I got number 14s, and I got two cable clamps. I'm just going to do the exact same thing here. I'm going to come down. I've got number 12s. I'm going to, if I look at table 314.16b, that's good for 2.25 cubic inch. I'll multiply that by 2. That's going to give me 4.5. The next one, ungrounded phase, or the grounded neutral conductors, 4.5. I've got four equipment grounds in there, but I only have to count one, and the largest is a number 12, so I have to take one. So that'd be 2.25 cubic inches. And then I got two number 14 ungrounded phase conductors and grounded neutral conductors. Well, if I look at table 314.16b, the number 14 is good for two cubic inches. Multiply it by 2, you get 4 and 4. You don't count the number 14 equipment grounds, you get 0. I got two cable clamps. I have to count at least one. That's 2.25 cubic inches. Add it up, gives you 21.5 cubic inches. Come down the cubic inch column, come all the way over to the left-hand side, pick the cubic inch that's above it, and I'll tell you the size square box you need, which is a 411/16 by inch and a quarter would be the minimum.
Yeah, and this is an interesting one too because this would kind of coincide with our myth. So you have two different overcurrent devices in this. You have a 15 amp overcurrent device and you have a 20 amp overcurrent device. So your bonding jumper would be sized off that larger size. So
That's
your
correct.
bonding jumper would be number 12.
That's correct. That's exactly correct.
Yeah.
All right. Now, this is where you get into the other boxes, and I said you'd have to use the chart or go online and look at the different sizes where you'd have a 4x4x4, a 6x4x4, 6x4x6, 8x6x4, something like that. Now, this, and we've got 8 number 12. All these are same size. We got 4 of them that are 8 number 12s, and we got 2 that are 4 number 12s. So all I'm going to do is add all these up, and I'm going to do this in circular mill when I'm doing other boxes. You're not going to do just one conductor for each because I need to know what the cubic inch fill is because I'm going to have to size my box by the cubic inch. And we
Right.
went over this last week. So if I look at table 314.16b, the number 12, once again, is 2.25 cubic inches. I've got 8 of them. I'll multiply that. That's going to give me 18 cubic inches for those first 4. Then I go down and I've got 4 of them. So I take 2.25 cubic inches times 4. That's going to give me 9 cubic inches. Add all that up together gives you 9 cubic inches. And then you take 6 times 4 times 4, and that'll be the next size that's up above that. Let me look here. Let me see if I got my calculator here. I'll tell you exactly what that value is.
So I want to bring up something real quick, James, and I think it's funny how this illustration kind of helps me talk about this. And we've come into this new myth that a lot of people talk about, where they're saying that you don't have 6 inches of free conductor in that illustration, you know.
Mm-hmm.
But running a pigtail with that splice in there is actually compliant for your 6 inches of free conductor.
Sure.
So a lot of people don't know that, and a lot of people think, oh man, you have to have 6 inches of free conductor from the back of the box, and there's a bunch of arguments that came off of my last post. So I really appreciate all the comments that everyone gave me, and kind of gave me a little idea of what kind of myths that I need to cover moving forward, so that we can bring these up. But that illustration kind of shows it that it's compliant as long as you're able to splice. You can even shove that back in the knockout. Remember that one?
Oh yeah. Oh yeah. I do. Uh, and that cubic inch was 96 cubic inches, so it was just right above 90 cubic inches for that size box.
Nice.
So now the great thing is, if you notice, I have not changed the way I do these calculations. I keep saying it
Nope.
over and over. I want people to understand you're not changing anything. You're just different applications depending on what you have here. Now, this one, I've got 8 number 10s. I got 10 number 8s. I've got 12 number 12s, and I got 5 number 6s. Now, this one, we put a note in here. We're not doing any equipment grounds here to keep it simple so people understand how to do the equipment or to get their cubic inch fill. But now, if I had equipment grounds in there, you're going to have a lot of equipment grounds. And we did a calculation the other day on this, showing where you did have the equipment grounds, and we showed we showed 20 extra in there, and then we showed doing that at a quarter and taking it at 0.25 and adding that additional count on there. Okay.
Right.
Now, this one here, if I go over and look at my 8 number 10s, well, what is number 10 good for? Well, that's good for 2.5. So if I take 2.5 per table 314.16b times 8, that's going to give you 20 cubic inches for the first two. Then if I got
Right.
10 number 8s, what's a number 8 good for? It's 3 cubic inches. So 3 times 10 is going to give me 30. I go down to it. Number 12 is good for 2.25. I got 12 of those. Multiply by 12. That's going to give you 27 for the next two. And then your number 6 is good for 5 cubic inches. So I'll take 5 times the 5 that I have there, gives me 25 for the next two. Total that up gives you 204 cubic inches. And then if I take and I do 8 times 8 and then multiply that by 4, that's going to give you 256 cubic inches, which will contain the next size above that. Will contain that 204 cubic inches. Now, that sort of wraps us up just on box fill. And hopefully
Right.
everybody has a good understanding now how to do the box fill and maintaining the same step-by-step calculation. Basically, what it comes down to, if you understand how to do step one for same size conductors and different size conductors, then you can lay everything out properly. Okay?
Yeah, and the one thing I like about this is like it's easy for us to show kind of like these younger guys like in the field. So like if we were to go and take that same illustration and just pull those conductors right straight through without splicing it at all, you wouldn't even need to splice any equipment grounding conductors.
No.
So a lot of that gets it makes it easy for us to teach when we're able to show these illustrations that James put together and show that hey, we could do this, we could do that. Like there's been times before where at the end of the show, James and I just sit there and just do illustrations and just make, and I'm like, hey, just do this color, use this, you know.
Mm-hmm.
And so it's a lot of fun to be able to express what we see out in the field and be able to show you guys how you can see it on a test. And when you see it on the test, you're going to know it on the test.
That's
You know,
right.
that's the important part.
Well, and one of the things that we like to do, and I don't think the other publications actually do this, I'm not 100% sure on it, but you'll notice we do round and octagonal, then we do device boxes, square boxes, and other boxes. And if you
Mm-hmm.
notice, all the calculations, it doesn't matter which box you're doing, it's still the same calculation. It's just
Right.
knowing the methods of counting your conductors. Once you got that, if you do multiples of these, and all of a sudden it clicks for you. Just doing one or two compared to doing 8 of them, and then that includes looking at the example problem that we do for them. You get 16 different types here to look at on how to go about sizing it, and it's the same calculation, just different type of box. That's it.
Right.
All right.
Yeah, and I really like that how you put them together.
Yeah, it takes time to do all that, but I think it's worth it in the end. Now, This is possible, could be on your test. They may want to know if you know how to do what the cross-sectional area of a conduit body is. And this, and we're going to show where you're connecting to a 3/4 inch electrical metallic tubing. Now, if you go over to chapter 9, table 4, and you pick up a 3/4 inch EMT raceway, it's going to tell you that square inch rating there is 0.533 square inches. And then all you're going to do is just multiply that by 2, and that's going to tell you what the cross sectional area of that LB is, which would be 1.066 square inches. It's a simple calculation. It doesn't take any time to do. You just have to remember where to get the square inch value from, and that's going to be in chapter 9, table 4, based on the type of conduit system you're using. Okay?
Right.
Now, next week we'll go over this, but you'll see in this particular one, we got a 1-inch LB here. Okay? And we got the LB. I think they did a really good job drawing the LB to show what it looks like and everything. And you'll notice we've got everything set up here for you to look at. The known values are here. We're telling you the type of conductors, but the main important part is we have a 1-inch EMT. Okay?
Right.
You'll go over and get that information. We even put in little calculation tips in here that give you some of the things to think about how we're going about sizing that. Okay?
So we went into a really interesting myth. You guys will have to look back at our other episodes where there was a certain code guy that said you couldn't splice in an LB. And I went and found one that was like 94.2 cubic inches. And I mean, you could splice like 41 number 14s or something in there. Like it was crazy. Like when I saw it, I was like, wow. I was like, this thing's like a junction box.
Well, isn't that funny? You look up there, you see we right on the right hand side of the illustration, we show it being spliced right there.
Right.
You see
Yeah.
the wire nuts there. The reason we do that is because that's why you need to know what the cross sectional area is, and that's why we have it in there. And
100%.
and some say you can't do it. Well, yeah, you can. It all comes down to you have the space in there. Now, this is not going to take that long. You're going to be looking at 314.28 A1 and A2. Now, if you're looking at A1, this is where we're going to deal with straight pulls, and when I get to A2, this is where you're going to deal with angle or U pulls. Okay.
Right.
Now, the first one's very simple, and this is what you need to remember. If it's a straight pull, you multiply by 8, and it doesn't matter how many conduits are added on there, it's still going to be 8. Now, if I have an angle pull, your multiplier is going to be 6, and you'll multiply the largest conduit by 6, but you have to add the others to it. Okay?
Yeah, we always say like out when we're out in the gas and oil, like straights are 8s, tricks are 6.
Yeah. Now, if I look at this, I've got one run a 2-inch raceway. So my multiplier per section 314.28A1 is a multiplier 8. So you just take the 2-inch raceway, multiply it by 8, and it tells you the minimum length of that pull box has to be at least 16 inches. Okay?
Yeah.
And then you'll get your illustration here. This one we're going to be doing a 3-inch. This is simple. You know it's an 8, 3 times 8. You shouldn't miss this. I'm not going to tell you the answer. Anybody knows how to multiply and knows what that answer is. And then if I come in here and I got a straight pull, I got a 4-inch, 2-inch, and a 1-inch raceway. Okay? Now, you're only going to take the largest one and multiply it by 8, and that's going to be your length. You don't add the rest of these to a straight pull. Okay? So I take the 4-inch raceway times 8. That's going to tell me I need to have a minimum length for that pull box there of at least 32 inches. Okay? And then you'll see here, this one's going to be a 4-inch. And you're going to see we did it on purpose. We put E and F there in the exercise problem. You know those are going to be 0. Okay? But the reason we put them in there because we wanted you to pay attention that you're not going to add the 2-inch and the 1.5 inch there. You're just going to put a 0. Okay.
Wow, I didn't know that. That's a good
Hmm.
one.
Yeah, I mean, there's reasons we do what we do, and some of this, and this is due. You're talking 80 years experience, probably really close to getting to 90 now, of things Dad and I've taught over the years, and watching what people do and what they get wrong, and then we just started doing things that we saw they were doing wrong, added it into the illustrations, and then if they put it there and then they check the answer key and see they got it wrong, they're like, oh shit, that's a straight pull. I don't want to put nothing on that. It's just one
Yeah.
time.
Well, and I think it eliminates the Z axis that some of the other educators put in their illustrations.
No, I know you're talking about there. All right. Now, here's an angle pull. I said the multiplier is going to be 6. In this case, I've got one run that's 4 inches. So I'm going to be coming at an angle. So I'll come from uh, we'll just say I'm coming from the right side of the box to the bottom side of the box. So I'm going to angle over to that pull. So in order to have enough length in there, I'm going to multiply that by the multiplier 6. So I'll take the 4-inch raceway by the multiplier 6, and that's going to tell you the minimum size of that box. It's just not for the straight. This will be the whole box. I have to be 24 inches by 24 inches because you're making pulls connecting from one side to from the side to the bottom side. So you need to at least have enough area in there to make that pull for the angle. So it'll be 24-inch by 24-inch uh, box. Now, this in here, we're just doing a U pull. It's a 3-inch. Okay. All you're going to do is take the 3-inch time what? 6. So you should easily know what the minimum length of the box should be here. All right. Now, when I get to an angle pull that has multiple conduits connected to its side, so say I'm on the right side of the wall, the box to the bottom side of the box, we've got a 4-inch, 3-inch, 2-inch, and 1-inch. So you're going to take the largest one at the multiplier 6. That's going to give you 24 inches. Then you add the rest of them together. So I got the extra conduits I have. I have a 3-inch, a 2-inch, and a 1-inch. That's going to give me 30 inches when I add them all together. And that'll tell you the minimum length has to be 30-inch by 30-inch box. Same thing when you get over here to the next exercise problem that you're going to work for your homework this coming week. You got a 3.5-inch, a 2-inch, and a 1-inch. Okay. And you'll just take the 3.5-inch by the multiplier 6 and add the rest of them together. And you'll notice in step 2, we have E and F in there. So you'll add those additional. Whereas if I was in the straight pull, I didn't add those other conduits. I only do it on an angle or U pull. Okay. And that gets you through uh, your pulls as far as having a junction box. So you got the straight pull and angle pull. Then what
Nice.
you're then what you're going to get into is sizing your conduits. Now, most learn this right away, but if you're going to take and all the conductors are the same size, you're going to look at Annex C. And then you're going to look for the type of wiring method that you're employing. At this point, we have an electrical metallic tubing, so that's going to be table C1. And all I'm going to do is go over there and I'm going to pick up the number 12, come down, find the size that's above the 10 number 12 conductors come across, and it's going to tell you that a 3/4 inch conduit will contain those 10 number 12 conductors. That's about as easy as it gets right there. And then you come over here, we got 4 number 6. Okay. And if you look, we're using rigid metal conduit. Now, when you get in and you start looking at this, make sure that you go over and you look at Annex C and you find the exact table that you're going to be dealing with. And then you're going to come across and look at the type of conductor. Because if you get the wrong type of conductor that's in there, this is a THWN. If you use XHW, for instance, or something like that, you're going to get a different uh, the possibility is you're going to get a different answer. So make sure you're picking up the right type of conductors and how many are in the the raceway, then come down, come across, and it'll tell you the size that you need. Now, when I get to different size conductors, we're doing one here that's electrical metallic tubing. The two sections you need to know here is I need to go to chapter 9 and I need to go to table 4 and table 5. Those are going to be the two. Now, in
Right.
order to get the square inch of the conductor, you want to remember you're looking at chapter 9, table 5, and make sure once again that you pick up the exact type conductor that's being used. Okay, because there's going to be a lot of different types of conductors in that table. In this one, we're using THWN. So in step 1, if I look at chapter 9, table 5, and I pick up the THWN copper conductors and I come down and I pick up a number 4, it's going to tell you the square inch value is good for 0.0824. For the number 6, it's 0.0507 square inches, and the number 8 is 0.0366 square inches. Now you come down, we had 2 conductors for the number 4, we had 1 for the number 6, and 1 for the number 8. So I'll take for the number 4, 0.0824 square inches times 2, that's going to give me 0.1648 square inches, and then I just had 1 for each, so I'm just going to bring the value of 0.0507.0366 square inches on there, and then I'll add that up. That's going to give me 0.2521 square inches. Now, once you get that, you've got all your square inch value here for your different size conductors. And then I'm going to go look at chapter 9, table 5, and you're going to look at the column where you have over 2 conductors there. Okay, so I'm going to come down to that column, find the next size that is above that 0.2521 square inches, which is 0.346 square inches. Then I come across and look, and it tells you you're going to need a 1-inch EMT for that installation.
Yeah, and just to add to this, James, I really like how you put this together. Um, you guys can double check yourselves. Like if you're really confident on this kind of stuff when you're in the test, you can actually see if some of the numbers aren't really jiving for like the answers. Like you're like, hey, wait a minute, there isn't even 1-inch EMT even in the answers. You know what I mean?
Mm-hmm.
Then what you could do is go back and kind of look at this and go, hey, how many number 4s did I have? Hey, how many number 6s? You know, so you can look at it, and that's why I like how James has it set up, because when you know this really good when you're in the exam, there's no pressure. You're able to just look at these numbers of these circular mills, and you're like, wait a minute, you know, this is not even on the chart. You know,
Yeah,
what did I do wrong? So you
and
can kind of go back, you can reverse double check your question fast because you know it. You know right away. This doesn't make it sense.
sure. And if you look, when we started designing the wiring methods, it's funny because when I was doing box fill, it was based on what? Same size conductors or different size conductors. When I get
Yeah,
over here to the conduits, what is it? Same size or different size conductors? You just
yeah,
got to know where to go get the information. And that's why I say if I'm doing boxes, you should get to where you know this. You should know I'm looking at 314.16 B1 through B5, and my tables are 314.16A1 or 16A and table 314.16B. If I'm doing my raceway systems, then I'm looking at Annex C for same size conductors, different size conductors. I'm looking at Chapter 9, Table 4, and Table 5. You
yeah,
should, when you go in, you should know that. And if I'm doing a pull box, then you know your 314.6 or 314.28 A1 and A2. And you
yeah,
know, I remember when I went and took my test, I had all those sections in my mind before I ever walked in. I knew where to
yeah.
go if I was asked that question. But I remember taking my test, I didn't get this question, but that's okay.
Right. Yeah,
And then you look here, we got 12 number 14s, 4 number 12s, and 4 number 10s. All you're going to do, we actually took in step 1, gave you the square inch of each one, and you go over and look at them, and then you'll see which conductor matches up with them. Then you go to step 2, add the number you have, get your total square inch, and all that's based on Chapter 9, Table 5. And then when I select the conduit, it's EMT. So you're going to look at Chapter 9, Table 4 for the EMT, and it'll be for over 2 conductors, which is 40% fill, which we show you there on the raceway in the illustration. Okay?
Right.
All right.
I like it.
Then the next one we get into is where you have a nipple. Okay? Now, we've discussed nipples before. That's something that's 24 inches or less. And in other words, it's not considered a raceway. Okay? So it doesn't matter how many you have in here. Since it's 24 inches or less, you don't have to concern yourself with the rating factors here. Okay? So we're going to decide what size nipple is required to enclose 36 number 12s. Okay? This is very, very simple. Okay,
dude, you need to let it go, man. Willie got 25 number 12s in that 3/4 inch, and just let it go. I mean, that's just amazing. Nobody's gonna do that again.
Well, one of the things we did is to sort of come in and show everybody how all this actually works, and we even show you when you're finding EMT at 100% fill. And if you look at it, it'll tell you how do I know what the fill is for 100%? Well, if you go over and look at Chapter 9, Table 4, it'll tell you it's 0.864 square inches. Well, the formula you would use to determine that is you'll take the diameter squared of the conduit, and that's also in the table, which is 1.049. You multiply that twice, basically you square it, and then you take it at 0.7854, and that's how they get the 0.864 square inches.
So okay? I'll tell you in confidence, Willie kind of told me the secret on this one when he was doing this, but he says 77% is the most you could ever get in any conduit. He says 77% is 100% fill. So I don't know how he's doing that math or whatever. I think he was using soap or some kind of weird fish tape, or I don't know what he was doing, but he said he could only get 77% max fill.
He's doing some good guesswork, man.
I don't know. I'm telling you, he said 100% is impossible.
Okay. All right. Okay. Now, let's look what can contain. Now, I'm going to tell you, this is the way we used to do the calculation, but now you can actually go over to Chapter 9, Table 4, and it'll have the 60% fill that shows you what that square inch is. Before they did that in the table, which was 3-4 cycles ago, you actually had to perform this calculation per Chapter 9, and you would look at Table 1, and then you would look at Note 4, and you would have to know how to take and get that 100% fill. And this was based on the information that was in Table 4, and you'd square it and put that 0.7854 on there to know what the square inch was in it. Okay.
Right.
So now when you look at this is how they do this, or this how we used to. If I go over look at Chapter 9, Table 5, and I pick up number 12, it's going to tell you for THWN that it's good for 0.0133 square inches. I multiply that at the 36 that I have in that neutral. That's going to give me 0.4788 square inches. Well, now, if you look there, we did the total fill percent, and we're telling you it's 0.864 square inches. If I take that at 60%, it's going to tell you here for the 1 inch EMT, which 3/4 would have been too small because we did the calculation. It'll give you 0.5184 square inches that will contain that 0.478 square inches. Okay. And then once you get that, you know that the 1 inch EMT is good to be used for the nipple at 60%. Okay. Nice. And I'm not sure if anybody shows that in their publications or not, how they squared this back here. But we've had people ask us, how did you get that? And then we go through, show them how to do it. And they're like, well, hell, that makes sense. Sometimes you got to go through that stuff to know what you're getting into. And then the next one you get, wait a minute.
Yeah, I think you need to add straps on your nipples, brother. You got floppy nipples in there.
What did I do here? Oh, okay. I'm right. Okay. I was looking at something else. Okay.
Yeah, see, there's a floppy nipple in there. You
So
can't have
you
those
got your
floppy nipples.
nipple here. We're showing you 60% fill. Now, if you look back at your old, when we were just doing conduit fill, it was at what? 40%.
Right.
Okay. This one's at 60% because it is a nipple. And remember, the nipple is 24 inches or less. You can go look at chapter 9,
Yes, sir.
table 1, note 4. It'll tell you all that. Then you're going
Yes,
to do
sir.
all your square inches, add them all up and everything here. And then you're going to determine what size raceway. We've already set it up for you. We're telling you, you need to look at the one that's 2.036 square inches here. So if you need to come up with that value. So you do some calculations, you'll figure it out. And then we'll go over it next week and I'll tell you what size it was and what you need to do and all that. But
Nice.
same calculation, we're showing you how to do all this and you'll fill that out as your homework next week. Then you get into an auxiliary gutter. Now, same concepts here. This one, I've got different size conductors here, so I need to go to chapter 9, table 5. And if I've got three 350s, I got three 1/0s, I got three number ones and three number twos. Go get your square inch value. For the 350, it's 0.5242, 1/0's 0.1855, number one is 1.562, and number two is 0.1158. You'll take all of those, multiply them by three. We had three in each one. Get all your square inch area, add it up. It's going to give you 2.9451 square inches. Now, the thing I want to point out, just like I did for the raceway, I did for a nipple, I had to go get all the square inches and just add up what was there. I'm still using the same sections here.
Right.
Then I'm going to determine, since it's an auxiliary gutter, I need to determine based on 20% fill here what I'm going to need. And you're going to look at 366.22a to get this information. So if I come back here and I look at this here, here's my square inch total value here, 2.9451 square inches. I'm going to take that and divide it by 20%, which is going to give me 14.7255 square inches. Then you're going to look at the box that'll contain that. So in this case, it's a 4 inch by 4 inch, which has a total cubic inch area there of 16 square inches. Okay.
Right.
Now, that they may ask you on this test, we're not sure if they'll do it or not, but they may ask, well, what if I get in and I want to know what I can use as far as my splices in that area? So all you would do is take that box at 75%. That's going to give you 12 inches, square inches. So we're telling you here that the metallic gutter is required with only 12 inches of gutter space used for what? Splicing conductors.
Yeah.
Okay?
And the one thing I want to tell all the apprentices out there is if you're confused on this in the test, just mark this for review and then go look at the actual definition. So, like, that was one thing that I did kind of wrong when I took my test was I kind of panicked and I didn't know what something said. I didn't know what it was and I kind of panicked and I guessed. And like you can't guess because the reason you don't guess is because you have guys like James Stallcup who are actually putting the wrong answers on there, and you have to know the right answer. So you have to know what these definitions mean, know what auxiliary gutter. Like if you go in the definitions, you'll see there's auxiliary gutter, there's trough, there's wireway. There's all these different definitions in there. You have to know exactly what you're dealing with. So don't just assume that a gutter is a trough or a wireway is a trough or a trough is a gutter, whatever it is. I think in your case, James, in this, that a gutter is a gutter, but like that's a hard thing. Like if you go look at Merriam-Webster's gutter definition, it's gonna tell you it's on the side of your house. You know what I mean? It's hard. It's confusing, and no, we're not trying to confuse anybody. We want you to know the truth and get it right the first time.
Sure. I'd look at an auxiliary gutter just like I do a wire where you still got to size it the same.
True.
So
And if you look at the definition, it says like an auxiliary gutter is a trough or something. You know what
Yeah,
I mean? It's confusing and so it's hard. You have to know that you're talking about the same thing, so you could cross reference yourself while you're taking the test. If you know all this and you say, "Hey, I just want to go look at the definition, see what a wireway is, what a gutter is, what a trough is, stuff like
sure.
that."
And especially when you're taking code, one of the things I always tell everybody, know your terms and definitions, because all you got to do is look in the back of the code book and it'll tell you what page auxiliary gutters are on.
Yes, sir.
All
I
right.
agree.
And then here's your homework for next week. And this is covering the auxiliary gutter here. And you just go through, work it just exactly the same way. You're still doing everything based on what? Square inch. And then when you take, just remember when you have an auxiliary gutter, once you get the total square inches, you divide by 20%. That's it. Okay. And
Right.
if they ask you how much square inch of the gutter can be used for splices, then you're going to multiply the box square inch, once you know what it is, by 75%. Okay.
Right.
All right. And then the last one we're going to do today is where I have a cable tray. Now, there's a lot of different cable trays we could done, but this is probably, if one gets asked, this is what they're going to ask. So we didn't do them all because there would be, you're probably looking at probably 12 different calculations we'd have to do for all the different types, because you get into communications and the large ones versus small ones. I mean, there's a lot of stuff you got to do there. But this is a normal question they would ask. It'd be based on a ventilated cable tray. In this case, we're going to show you have 12 250 casing mil and 8 1000 casing mil. Now, all you're going to do, like we start everything off, is you're going to look at Chapter 9, Table 5. You got to get the square inch of each one of those conductors. Okay? So for 250 casing mil, it's 0.397 square inches. For 1000, it's 1.3478 square inches. We had 12 of the 250. That's going to give me 4.764. And we had 8 of the 1000 casing mils, going to give me 10.7824. Add all those up together, gives me 15.5464. Then what you're going to do, you're going to look at table 392.22B1, pick up column 1, and it's going to tell you the next size above that's going to be 19.5 square inches, which is going to require you to have an 18-inch wide tray. Now,
Okay.
the thing is, I like to point out here, if you notice, everything's still the same. It's just you got to get those square inch values, get the total, then you guys got to know which tables you go to in order to apply the proper section there to do your sizing. So
Yeah.
here we got 10 1000 and 14 300 kc mil. Going to do the same thing, get all your square inch value, then you're going to go over, look at the table, come down, the next square inch size above that, then it'll tell you what that cable tray size is going to be. Okay.
Nice.
And that will
Yeah.
do it